Good evening, sir.
Good evening, Anmay.
Hey, sir. Can you just stop sharing your screen because I'll just share my screen for 2 minutes. Then you can continue.
Sure, sure.
Thank you, sir. Participants are requested to wait because we'll be starting the session in few minutes. As also more participants are joining, so just wait for few minutes. We'll be starting with the session. Participants are requested to wait for a few minutes. We'll be starting just by 4:25. So kindly wait. We'll be starting the session soon. And sorry for the delay. Hello and welcome everyone. I'm Anmay Rane, your host for today's webinar. My team and I are here to make sure you have a seamless and engaging experience. If you have any questions or need any assistance, feel free to use the chat window. We are here to help. So today's topic for webinar is fine-tuning an LLM on Amazon SageMaker. Talking about synergetics. So today's event is sponsored by Synergetics. Before we dive into today's session, let me take a moment to introduce Synergetics. Synergetics is a leading edge learning solution provider in India, offering specialized training and consulting services. So we empower businesses and professionals to thrive in today's fast evolving tech landscape by delivering transformative learning experiences. Our core focus is on enabling digital transformations through innovative skill programs, advisory services, and end-to-end implementation support. From modernizing IT frameworks to mastering emerging technologies like AI, cloud computing, and DevOps, Synergetics is committed to equip you with the right tools and right knowledge to succeed. So this is the Microsoft certification skilling journey on the screen. So the journey begins with the fundamental certification, then progresses to advanced role-based certification, and then finally to expert level certifications, which can help build you a long lasting skills. And we are thrilled to have Mr. Chandrasekhar Deshpande as our today's speaker. So he is a certified Microsoft trainer and a consultant of Synergetics. He brings a wealth of knowledge and experience in AI and cloud technologies. The agenda of our meeting is to understand ML, neural networks, and generative AI. What are large language models and small language models? Types of Gen AI models, techniques to improve the model performance, what is fine tuning of the model, types of fine tuning like supervised fine tuning, instruction based fine tuning, and parameter efficient fine tuning. Overview of Amazon SageMaker, demo and fine tuning of LLMs in Amazon SageMaker. So we run communities on Meetup. This is the emerging technology community. Anyone who are eager to learn about technological knowledge can join this community on Meetup. We have multiple communities in Pune, Gujarat, Nagpur, Indore, and those who are interested to join this community, please log into Meetup app and gain your knowledge fee. Do follow us on social media platforms to get relevant updates on upcoming webinars, workshops, certifications, and also I'll be sharing the link in the chat box so you can follow us through that. Thank you and thank you for listening to me. Now I would like our speaker to hand over the session.
Thanks, Anmay.
Thank you, sir.
I welcome all of you on this 1.5 hour session now. It's on fine-tuning LLMs on Azure SageMaker. I will share my screen. So whoever has joined here, I believe, they already are aware of they already have basic understanding of this topic, what is generative AI and other things. Still, just to warm them up, I will go through some of the concepts very quickly. So, yeah, these 3 points mainly we will try to cover in our discussion. First of all, let us quickly understand what exactly generative AI is. Okay, I will be trying to cover some of the basic understanding concept quickly so that we will be in position to give sufficient time to cover one demo. That demo will give you a clear-cut idea about how fine-tuning can be done on AWS. So it's all about artificial intelligence. Artificial intelligence basically is mimicking the human intelligence, and in many cases going beyond that also. So a field of computer science that seeks to create intelligent machines that can replicate or exceed human intelligence. Thereafter, we saw uh, the era of machine learning, where machine learning, which are all mathematical or statistical algorithms, can be used to do future predictions. So it is a subset of AI. Remember, artificial intelligence is an umbrella term within which machine learning, deep learning, and generative AI, all these are the sub-terms. So subset of AI that enables machines to learn from existing data and improve upon that data to make decisions or predictions. So here to machine learning, I believe everybody knows. I'm just trying to, take you through these topics just to help you to recall that in machine learning, you submit huge data to machine learning algorithm, and thereby that phase we call it as a training of the machine learning model. So once that model is trained, we may try to evaluate its performance. We may try to apply different measures to get the best performance out of it. And thereafter, once we get machine learning model with the best performance, then that model can be used in the production. And in production, then thereafter, in case if you submit it some basic data, it has to do the prediction. So we saw a machine learning era where there are different types of algorithms like regression algorithm, classification algorithm, and then so these types of algorithms are already there. Those algorithms we already discussed in you might have gone through. Thereafter, in order to deal with more complex problems, uh, going beyond machine learning and dealing with the more complex problems. So there we saw deep learning also, and in deep learning, natural language processing, image analysis, and like those things we discussed, sorry, we saw there. So it was the next step beyond the machine learning to again try to mimic the intelligence of a human being. So there we saw image analysis, object detection within the image, and in natural language processing, we saw analyzing the audio, analyzing the videos, and those things. Now here in 2020, we can see generative AI, which basically talks about giving it a command based on natural language, and according to that command, it has to create some document for you. So natural language input to it and natural language output from it, natural language response from it. Now, what is the difference in between natural language input and natural language output? That natural language output is a kind of a descriptive text, obeying the given command as a natural language input, and that descriptive text basically, is innovative, is like mimicking a human intelligence, and thereby writing a mail for you, writing a description for you, writing a proposal for you. So that kind of thing we can expect from generative AI to uh, work for us to create a new written visual, new written document, visuals, and auditory content given prompts. Now the input, that natural language input that we are giving to it, that is called as a prompt. Okay, so when we submit it a prompt, then it accordingly writes a description for us, or creates a visual for us, or create some music, audio for us, auditory. Yes. So now we are in a generative AI era, okay, wherein we can see different types of assistants working for us. We may call them as the co-pilots also. So there may be a co-pilot in Microsoft 365, co-pilot in Visual Studio Code, which is helping us out. We are pilots there, We are doing a main thing, and the co-pilots are helping for us. In Visual Studio, you will see co-pilot will interact with a generative AI model, okay, to write a code for us. So we may ask Copilot to do the things for us. Copilot may interact with a say generative AI model, and accordingly, what your code generative AI model writes for us, Copilot pass it on to us. So that's how this generative AI may help us in even writing the code also. There is always a question that what is the difference in between generative AI and machine learning. The difference is huge. And here you will see on multiple fronts that generative AI is next level of artificial intelligence. So here, if you see machine learning has a goal analysis and predictions, okay, it can do analysis on the data. It can do future predictions for us. And machine learning basically more or less is limited for data analysis and prediction. On the other hand, generative AI can create and generate documents, codes, images, audios for us. So huge difference. And goals are also different. Here you have to give, in machine learning, you have to give medium-sized business data, and based on that, that model, that phase to which that phase in which we submitted the data, and that model, uh, gets itself aligned with the data and gets itself ready for the predictions. That phase is called as the training phase, and thereafter, then actual prediction when it does, that happens in the production phase. Okay. As far as generative AI is concerned, it needs a large and very large size of general and business data. Now, here when I say general, what this general means is that general English text is to be submitted to it, okay, which it goes through to understand how it will write elaborative text in English or elaborative text in any other language. Similarly, in case if you submit a business data to it, while writing this general text, it will use the business data, okay, so that it aligns its result, it aligns its responses, okay, to the uh, business interaction also. Insight, classification, these are all outputs of machine learning. It can give you insight of the data, it can classify the data, it can do the predictions for you. Okay, on the other hand, generative AI basically is for creating different artifacts, contains new data also. Okay, sometimes what happens that you are in the area which is perhaps new to you and you have not much data with you. Okay, in that case, uh, uh, the new data generation, generative AI can be used to generate a synthetic data, to generate the synthetic data for you. Okay, focus. It's machine learning focus is actually existing data, understanding existing data. Okay, generative AI, it understands existing data, but for what? For designing content. Okay, new contents. Many such examples can be given as a set of use cases for machine learning. That customer segmentation means whenever bank has millions of customers, bank can go through all types of their financial transactions and go through financial profile of everybody. Okay, thereby can create a segmentation of the or categorization of the data. Uh, all the customers with you know uh, silver level of transactions, gold level of transactions, platinum category transactions. So depending on their financial status, customers can be categorized. Spam detections, anomaly detections, predicting whether future sale of the company. Lots of predictions related things can be done using machine learning On the other hand, generative AI basically is for any kind of image generation. So there have been, books published. There have been books published, okay, written by generative AI, full of images where every image has been created by generative AI. So, not many such examples can be given uh, of the application of the generative AI as on today. Its um, innovation is literally unbound. Because of that, fraternities are also, feeling fearful of using all the features of generative AI. Just to cite you an example, I give you an example that there are books written by generative AI. Similarly, there are music created by generative AI. So somewhere, there must be a cap on what kind of innovations it can do. And yes, today, as on today, many of its features have been restricted, limited uh, to prevent their misuses. Okay, but otherwise, generative AI is an idea, which is really unbound. Okay, text generations, music creations, emails, and proposal creations. Next slide, the training data size. Now, this is here you will see some technical differences. So, medium-sized business data for machine learning, it doesn't need very large data size. Okay, but for generative AI, very high volume of generic and specific data is needed. When generative AI is trained on more and more data, you will see its performance increases leaps and bounds. Okay, so generative AI basically, its training phase is very strenuous and extensive. Its training phase takes a longer time as well as its training phase, uh, say, takes a critical large hardware also. Okay, costly hardware also. So, machine learning models can be very frequently or regularly trained that may not be seen for generative AI. Okay, because generative AI takes a larger time to get trained as well as costly hardware upon which it has to be trained. Model types. Using algorithms of the type of supervised, unsupervised, we know in machine learning, supervised and unsupervised algorithms are there. For generative AI, deep learning models and processes at the heart. Small or large language pre-built models available in catalogs and gardens. Now, here one very important point to note is, as I already mentioned, that generative AI models are to be trained on very large hardware, on very large data also. For this purpose, what normally is preferred is, in order to train the model right from the scratch, what they have done is small or large language pre-built models are available. Pre-built means on generic data, these models have already been trained and they are available on cloud. So there are gardens on GCP cloud, there are catalogs on uh, Azure cloud, as well as there are many such models available on AWS cloud. Besides that, there are third-party uh, say models catalog available like Hugging Faces or so. Okay, so what is a trend like on today? That no company tries to train the model from the scratch, but instead what they do is they refer to already trained models. We call them as the pre-built models. So GPT is one of the pre-built models. As we will go here, we will see GPT series, Llama, Bard, etc. So these are the different models available as on today. Okay, medium size for training infrastructure, machine learning needs medium sized machines, but for generative AI, machines are high end and costly also. Okay, so these are all differences, and looking at these differences, it is pretty clear that what machine learning can do today, Generative AI definitely can do. Generative AI can do predictions also. So generative AI is the next level of machine learning. Okay. Now here, how does it work? So you have to submit a prompt to the large language model. These prompts may contain what exactly you are expecting it to do. You may be submitting a couple of examples to it. Means, in case if this is a question, what kind of answer do you expect? Okay, we call them as a few shot learning. Okay, and in that case, the model creates an answer, and accordingly, it responds. It's a response can be anticipated. That response is called as a completion. So it does a completion. It creates a response which is called as a completion. So prompt is actually a natural language statement. We have to fabricate and submit to it. That prompt should give it not a vague but very clear cut idea about exactly what do you expect. Like in case if you want it to write a mail, you have to mention what are all topics it should cover in the mail. You may not elaborate every topic in detail, but exactly what do you expect from it to do? How do you want it to write a mail for you? That uh, must that thing must be clearly explained in the prompt. Such a prompt on submitting to it creates a response and thereby it returns with a response. Now, what are large language models? We have seen generative AI models, okay, but there they are also called as the large language models. As on today, lots of such models are around us. So GPT models are there, DeepSeek model is there. Okay, so many such models are around us, and we are getting free access to such models. Okay, to know to use their power in our day-to-day life also. A type of artificial intelligence that excels at processing, understanding, and generating human language. For machine learning, there is a regression model, there is a classification model, but for large language models, for generative AI, there are large language models. Now, there are small language models also and large language models also. Here, small language models basically are the models which may not be trained on very large generic data, which basically are trained on the business data, and they are not meant for a general purpose. Okay, but small language models are basically meant for uh, to get aligned with the to get its responses aligned with the company's needs. So small language model is a model trained on some specific company data, and thereby that language model can create a responses which are aligned with the company's needs and company's expectations. But if you want that model to create emails for you and what everything that you expect from any kind of generic model, then that model has to be very extensively trained on very large data. Okay, such models are called as the large language models. As on today, whatever models available there on the cloud, pre-trained models which are available in the cloud, all are large language models. They are trained on vast amount of data, use deep learning algorithms to learn the patterns and relationship among between words, phrases, and sentences. Okay, the underlying transformer. Now, see, this large language model has something called as a transformer at its heart. It has transformer at its heart. So, transformer architecture is a neural network kind of architecture, around which generative AI models have been designed. In transformer architecture, I may be using some terminology like encoder, decoder. Fine. In today's discussion, the discussion on those terminologies are out of scope. But otherwise, these transformer models and that architecture basically at the heart of these large language models. Transformers work on self-learning and unsupervised training. So self-learning is there, that these transformers keep learning from whatever prompts you submit to it, what your responses it generates. Its prompts and its responses keep evolving for itself, and you will see with every interaction, its responses are a bit mature than earlier. So these models keep learning from their responses. They perform various natural language processing tasks such as text generation, translation also, and question answering. They have demonstrated emergent abilities. LLMs can further be customized for specific tasks. Now, this last sentence is very important. LLMs can be further customized for specific tasks by fine-tuning them on smaller, more specialized data set. Now, see, whatever LLMs available on the cloud, can be Bard, it can be Llama. They are trained, they are pre-built, but they have been trained on generic data. They do not know, in case if there is a specific vocabulary, terminology your company is using. They even cannot answer your company specific questions because they haven't been trained on your company specific data. So fine tuning is essential. Fine tuning is actually retraining the model on company data. That is actually a fine tuning. So fine tuning is essential on such data to make those models, highly performing for your company. So highly performing means the responses should be what your company is expecting. The responses should be using all terminologies what your company is using. The responses should be revealing, data of your company. So in case if you put a question like, what is uh, aggregated sales data of the previous month, so definitely that model must be aware of sales data of previous month, okay, and thereby it should create a report for you. So fine tuning is necessary for this purpose. So fine tuning is a kind of retraining these models on uh, enterprise data, specific kind of enterprise data. There are multiple types of generative models. Base GPT model, Llama, are best GPT model. Has been invented by OpenAI. Llama is there and Bard is there. Many such models are available. Okay, multi-model systems are also available. Embedding models are there. Image designing models are there. So image designing models means you will ask what kind of image do you need, and it will create an image for you. Okay, embedding model means where large text data is converted into its a binary form, that is called as an embedding model. So embedding models help to quickly find very large quantum of the data, quickly find a specific data out of very large quantum of the data. So that also helps in generative AI model functioning. Okay, so multiple such types of models are there as on today. Here you please quickly go through the kind of the prompts that can be submitted to such models so that models will revert to you. Classifying content. Okay, I enjoyed the training course and I wrote there the word sentiment and I left this place. Okay, and this place I am expecting generative AI model to complete. That's why its response is called as a completion. And what it is going to do is that it will go through the text that you have submitted to it, and accordingly it will identify whether this text is with a positive sentiment or negative sentiment. Translations. So hello word may be translated to French, but while giving a prompt, how you will give it, that you will fill up some data and you will leave this place empty so that it has to understand that you need a conversion translation of word hello into French. and thereby it has to return to me translation of the word English word hello into French word as a bonjour. Summarization, you may be writing large text there, and then at last you may be asking it to summarize the text. It will have to return a summary of the text. So here you may be submitting 3-4 paragraphs of the text, and thereby you will be receiving only one paragraph having a summary of what were mentioned in the 3-4 paragraphs. Continuation, one way to grow tomatoes is to, okay, this is what a prompt you will submit, and it will try to complete uh, that sentence, okay, with a continuation. Question answering, okay, chat. So here there are multiple ways to submit the prompt, and in order to learn different techniques, tools of submitting the prompt, there is a separate uh, branch uh, established called as a prompt engineering. Okay, so as on today, this prompt engineering also has demand in the market. Okay, this is one URL. Let me put in chat so that you too can refer to it. Okay, so here it seems we are ending this section. Okay, I would like to ask you any question on the section that I have just completed, so that after having a discussion on that, I can go for the next section. So any question, please. You can unmute yourself and put your question. Hello. Let me know whether somebody has any question. You can keep putting questions here in the chat so that, when I will come back to it, I can have a look at it. Fine. So, though pre-built models are available on the internet today, none of the company can directly use them. Specifically, if that company, wants to make it more effective for themselves, if that company wants to align or to expect all aligned answers from that model, okay, there that model has to be retrained on company data, and that is called as a fine tuning. What happens in case of machine learning, in case if you are from machine learning background, machine learning models are to be trained after regular interval for the reason that there happens to be something called as a data drift. Data drift means whatever be the pattern of the data till last week, that pattern changes in the market. Okay, as market keep changing these patterns because of the steep competition in the market, and there may be extra uh, territorial factors. Territory means the territory in which company works. Okay, there may be extraterritorial factors, competition among the market, among the companies, because of which data drift is bound to happen. And for such a data drift, you know, performance of the model goes down. Performance is now here for model performance is counted in terms of accuracy in the prediction. So that performance goes down. Okay, on the same line, here what happens? Here performance does not go down that way, but you need to fine tune the model to help it to align its responses as per your expectations. So here you don't need that model to be so frequently retrained, but once in a while you may have to retrain the model uh, to expect its performance, sorry, to expect its responses aligned with the company expectations. So here you don't have to retrain the model so frequently like machine learning. Okay, here you have to retrain the model maybe, for example, today we have retrained it on the sales data, and tomorrow, then in case if we decide to, retrain it or to expect its alignment for the research data, so we may have to retrain it tomorrow on the research data. But once we have retrained it on the research data, we don't have to retrain it so frequently after every month, after every week, or after every 6 months. Okay. So there are multiple ways to increase the performance of generative AI model. Every organization uses its own terminology. Organization expects from Gen AI to align its responses. There are different strategies to enhance performance of a model. To improve the quality of the responses the model generates, you can try various strategies. Now, here a couple of strategies have been mentioned, and now I will expect everybody to pay attention, okay, because the real stuff is now beginning. Prompt engineering. In case if you properly construct the prompt, okay, thereby, model will also get a clear-cut idea of what exactly you expect. Sometimes, in case if your prompt is vague, at that time model does not understand properly your expectations, and thereby you do not receive the response as per your expectation. Okay, so designing the prompt is very important here and very crucial step here. But sometimes what happens is, because of the lack of the knowledge, even if model gets clarity, still because of the lack of the knowledge, that model cannot create a responses as per your expectation. So there you have to realize that the prompt has a limitation beyond one limit. Prompt cannot help model to create a response as per your expectation. There you have to increase the knowledge of the model, and there we have two steps: RAG and fine tuned. Now, what is RAG? So along with the prompt, you may be sending some ground data to the model. Along with the prompt, you may be sending some ground data to the model. It means some data that increases the knowledge of the prompt that also can be submitted. Sorry, some data that increases the knowledge of the model, that can be sent along with the prompt. That is called as a RAG. So RAG actually augments the prompt, okay, with some additional knowledge. And when that prompt goes there, that model, uses that knowledge, to create a responses as per the prompt. So in prompt, this additional data is submitted. You don't have to explicitly submit it. Okay, you simply have to make an arrangement, and thereby your system, ensures that data to be submitted to the generative AI model automatically, okay, whenever you create a prompt. Okay, ground your data by first retrieving context from a data source before generating a response. If you consider that it is a law model which has been trained on very huge quantity of law related data, different cases and their hearings. Okay, and now here your prompt is to get a response from the model on one specific subject. One specific subject. Okay, law related subject maybe. Here what happens is that model will try to get that data from the thing that model has already been trained. But in case if you also can design a system where on that, say, for that subject, first of all, your system does a search in a specific subject. Okay, search that uh, say knowledge base, gets the knowledge base on that subject and sends that knowledge base as a part of the prompt to the model. Model not only will work on the data what it has, it will also use the data that has been searched. by the system. Okay, and thereby then it will revert to you. So RAG is one more feature there, but in RAG, what happens is every time you have to send in the prompt, you have to send the ground data to it every time. That thereby, size of the prompt increases because it has to be, augmented with the ground data. Okay, and it may affect the latency of responses also. Okay, so thereby then, in case if you realize that every time sending the data, some ground data as a part of the model, okay, this is a one way possible, or another way possible is instead of sending that data every time to the model, why we don't train that model with that data itself. That is called as a fine tuning. So fine tuning basically is making the model to learn from the new data. Train a base language model on a data set before integrating it with your application. So see from this diagram, this is on retrieval, RAG. User sends the query. That query first of all goes to the retriever. Retriever basically is a kind of a reservoir of the data, where it will do a quick search in that reservoir on the subject on which the query has been sent. Okay, so relevant text it will bring from that reservoir of the data. It will accordingly put that data into the prompt, and that whole prompt will go to the LLM. So query what user has given, the text what it has received from the data source, that goes as a part of the prompt to the LLM, and thereby LLM that creates a response. So designing this system is always been something as a part of the RAG. Now here in this system, okay, you not only have to have a data source, you have to have a system which is very fast in searching a specific kind of data from the reservoir of the data. Okay, this searching has to happen very fast, and there, it is challenging in the sense that here you will see uh, lack of performance, increase in the latency in responses, because it happens in two phases. In one phase, it has to search for the ground data, and in second phase, then LLM has to create the responses. So this becomes a two-phase system, and that's why, in case if you have not very large size of the data, this system will work. RAG. But whenever your size of the data increases, okay, there then you have to use fine tuning of AI model. In fine tuning of AI model, what happens that you have to retrain the model on the new data. So pre-training LLM, this is your pre-trained model which has already been trained on generic data, and then here you have to apply a retraining on the data, and here then you will get a fine-tuned model. In order to apply today's topic is on the fine tuning. Okay, in order to apply a fine tuning there, okay, involves adopting pre-trained models to specific tasks or domains. Okay, this process builds upon models' existing knowledge to achieve better performance on a particular use case. Particular use case means training the model on our company's sales data. Thereby, it will be in position to create answers for you yeah, on the prompts related to sales data. Okay, so there are three common methods here: supervised fine tuning, instruction based fine tuning, and parameter efficient fine tuning. I will quickly go through three of them, and after that, then we will begin with a demo. So, supervised fine tuning. I will come back to this set of use cases later. First of all, let us have a look at a supervised fine tuning. In supervised fine tuning, first of all, let us understand quickly. Process of adopting a pre-trained model to a specific task using labeled data. Here, you need two things. One is a pre-trained model. It may be Llama. It can be GPT. Okay. You need a pre-trained model. That is one thing. And second thing is you need a labeled data. Now, what exactly this labeled data is that we will see on the next page. But only two things we need in supervised fine tuning. This involves updating the model's parameter based on the data set where inputs are paired with the corresponding desired output. How so whenever you are submitting the data, what happens is that you have to submit a pairs, means a raw answer, what it may be giving you right now, and improved answer. What kind of answer, what kind of improvement you expect in that answer. So maybe raw answer is very straightforward, but in case if you want the improvement of elaborative answer, then raw answer and elaborative answer. Okay, such type of answers are submitted to it as a knowledge base, and on such a data, it is trained. So again, I repeat that in case if I ask it a specific question, um, like what is a current uh, war level scenario in between India and Pakistan? Just one arbitrary question. It may be giving me answer very briefly, okay, that it is very tense and though not escalated, but there are high chances of getting it escalated. That's over. Okay. But if I submit this, if I want this answer to be more elaborative, okay, in that case, then I will have to train that model on these are two sentences responses, what it gave me earlier, and what elaborative response I want from it. Okay, so in elaborative response, a similar scenario with enough empathy, with enough creativeness, it will explain to me. And in order to do that explanation, it may take a couple of paragraphs also. Okay, so such types of answers, if I submit to it and if I retrain it, okay, that is supervised fine tuning. And why we call it as a labeled data? Because here raw answer you are submitting and modified expected answer that also you are submitting, that is called as a labeling, labeled data. Okay, paired data. That's why we call it as a supervised fine tuning. SFT is supervised learning method, meaning it relies on labeled data to guide the model learning process. Okay, from this diagram, it will give you more sense that if you are submitting an answer something like this, I can't log into my account. What should I do? And here is its answer. Try to reset your password using forgot password option. This is very straightforward, which is answer without any empathy. Okay, so such answers you will submit and the answer what you may want, you are expecting from it. Such answers, you may submit to it, and after that, if you train it on such question answer pair, sorry, not question answer pair, but raw answers and modified answers pairs. Okay, thereafter, in case if you submit it as a question, something like this, its answer will be with full of empathy. I'm sorry to hear you are having trouble logging in. You can try resetting your password. So see difference in between its way of answering and here its way of answering. Okay, so that is something called as a SFT. Okay, here another way of fine tuning is instruction based fine tuning. Okay, I am planning to show you a demo on this on instruction based fine tuning. Okay, in instruction based fine tuning, what happens is, let me quickly brief you on this, that you will create question and answer, prompt and its expected answer. So hundreds and thousands of prompts and hundreds and thousands of expected answers. Okay, and you will train that model on that. So that model basically comes with a generic learning. Okay, and here you will instruction output, instruction data set you will submit to it. You will train that model, and thereafter you will realize that model answers are more aligned with the question and answer pairs what you already have submitted to it. Okay, so that's called as the instruction based fine tuning. I will show you demo on this. Then lots of such types of data. I mean to say data sets are available on the internet. Which you can use. These data sets are basically for prompts and their ideal answers that way. Okay, so in case if any small brother of yours, is attempting for 10th examination or 12th examination, he refers to guide, guidebook. In Hindi, we call it the Guru Kildi. Okay, so when he refers to it, there you will see the question and corresponding ideal answer. So such type of data, if you use to train the model, you will see that model shows you alignment in answering. Last one is parameter efficient fine tuning, FEFT. Here in parameter efficient fine tuning, what it does is low rank adoption and quantization and low rank. Here what it does is that it identifies, these models, in case if you are coming from machine learning, in machine learning, there are hyperparameters. For some algorithm, there are 2-3 hyperparameters. For some algorithm, there are 50-60 hyperparameters. Here for generic AI models, there are millions of hyperparameters. Millions of hyperparameters. So in PEFT, parameter efficient fine tuning, this process basically identifies those hyperparameters which are showing more effect on its responses. It identifies those parameters and accordingly it adjusts those parameters. So there may be millions of parameters. It will not adjust all the parameters. It will adjust only those parameters which are showing its effect on the responses generated by uh, generic AI models. Okay, and thereby with those adjustments, then your model start giving you more performance. There are two types of models: low rank adoption, LoRa, and quantization and LoRa. Okay. Anyway, discussion on these in further detail is beyond our today's scope. Now, let us come to the last section. Amazon SageMaker. We will use Amazon SageMaker here. There are two services available on AWS to help you out on generic AI development, generalized AI development. One is the SageMaker. SageMaker basically is for developers, and Amazon Bedrock basically is for those who would like to code much. Okay, for them, ready models are available on Bedrock. But in case if you want more and more customization, you are suggested to go with a SageMaker AI. Earlier, it was known as a SageMaker. Now they are calling it as a SageMaker AI. So it is the next generation of the Amazon SageMaker. Okay, and here you can do complete end-to-end development of the model, and you can fine-tune the model, and you can align the models for your company needs. Amazon Bedrock is a fully managed service that simplifies the development of generative AI applications by providing access to a variety of foundation models. But for great level of customization, I will always say SageMaker AI is best to go with. What SageMaker can do: SageMaker AI is there, SageMaker Lakehouse is there, data and AI governance it can do. It has its own catalog also. Lots of things it can do. Okay, I will go ahead now. See this architecture. Here you have to select the model. We will select Llama 2 recent version. Okay, we will have to fine tune it, and finally we will have to verify its performance. After we are satisfied with its performance, then we have to deploy it. For the deployment, deployment environment may be available in Bedrock or wherever it is available, that model can be deployed there and production can be started. While fine tuning it, you have to train that model on the custom data set. Here you will train it on the custom data set. So that is a top level architecture of the uh, fine tuning, instructor based fine tuning, instruction based fine tuning. Lots of models are available there in SageMaker. We will use one of these models. Yes. And now let me go to the demo. Now, I already told you that these models are to be trained extensively. Okay, that is one thing. And another thing is they are training, they are testing, not testing, but their training always take a longer time. Their training always take a longer time. So what I did is, for convenience here, because here we do not have uh, much time available. Okay, so I already have deployed one model for you. Okay, so I will just take you through that model. So here you see what I did is, and I hope here you know at least basic terminologies of SageMaker, like SageMaker Studio. I started with. Okay, and in SageMaker Studio, here I want to go with a jump start. See here, these are all public models available. Okay, very long list of public models available here. Either you can use these models directly for the production, or some of them you can use for the purpose of the training. Okay, retraining. Not all the models are available. Not every model is available for fine tuning. Some of the models they have kept open for fine tuning, while some of the models they have uh, forbidden for fine tuning. Okay, so here what I have done now, I will take you through the steps also, Python steps. Okay, I have created two deployments here. This one deployment which I created earlier, 1.21, 1:21. Okay, this is on only pre-trained model, bare pre-trained model. Okay, and this another deployment, what has happened here on 137, it is of the trained model. Okay, so we have two deployments here, and I created both these models and I have deployed them. What do you mean by model deployment? That model training is not sufficient. After model training has been done, it has to be made workable in production environment, and that production environment is called as a deployment. So here we have two production environments. One is for the pre-trained model, and another is for the trained model. Okay, here is the code. I Now this is the Jupyter notebook. This is Jupyter notebook. Any kind of editor you can use. I have preferred here to go with a Jupyter notebook. Okay, in Jupyter notebook, I did install all necessary libraries for using SageMaker API. So here I have installed the libraries. So here you can see the command pip install upgrade SageMaker dataset. So dataset library I have installed here. Okay, I did not install model library for the reason that that model library for llama has already been available here. Okay, deploy pre-trained model. So I will be using this model for the deployment. This is llama 2. Okay, not most recent version, but fairly recent version. Most recent version is 4.31. I am using here 4.14. Okay, so model ID meta text generation llama 2. Okay, model version 4.14. And here you will see Jumpstart model. Jumpstart model is a class available in SageMaker. Import Jumpstart model. Okay, to which I am submitting model ID and model version. And here I will get a model. This is generic model, generalized model. I repeat again. This is generalized model, pre-trained model. You can use it for drafting your emails and other things, but this model definitely lacks your company database, your company level knowledge. Okay. Pre-trained model. Here is the deploy method, what we are calling. And after, the deploy method is called, here, this endpoint is created. This endpoint is created after you deploy the model. Okay, so this execution of this particular statement, okay, will lead to creation of this endpoint. This endpoint will be created because of that execution of the deploy statement. So model will be deployed, and once it is deployed, we can we can verify the execution of the model. So here you see one method I am writing, which is just to print the response. Okay. And here what generated, see, payload and response. This method will receive two parameters. And out of those two parameters, the response, it will print the payload here, and it will also print the response. Now, in the response here, see, exchange of the data happens in the form of the JSON. So payload is also in the form of the JSON, and response is also in the form of the JSON. From that response, generated text is a field we have to extract, and print. So thereby we will come to know what response we have received from the model. Okay. Now here see how we are designing payload, and then how are we uh, connecting to the model, submitting the payload and receiving the response. Here in the payload, you will see this is the prompt what we are submitting. I believe the meaning of the life is, see, this is incomplete statement. And I want that model to complete that statement. Some parameters I have to submit. Again, in case if you already know the generating AI concepts, top P, these are all hyperparameters. Temperature, these are all hyperparameters we are submitting. Okay. And this payload, when we submit to it, okay, here we are submitting a payload. And this is basically attribute to be submitted uh, to give it, say, assurance that we are abiding by its license. Okay, so you, as of now, you can ignore it. Here you will get a response, and then you are submitting that payload and that response to this method. Thereby, you will receive the result from it. I am putting it to run. See, only this much I am putting to run because my model, pre-trained model, has already been deployed in this statement. Here I already have deployed it. Okay. Now let me put this statement to run. So let me see its output. I believe the meaning of the life is, and here it has completed your sentence. To fulfill your dreams, I am a pretty strong believer in the power of the dreams, and I also believe that world is a constant state of change. If you think about it, you live in a society where things change almost daily. It's important to take note of these. Anyway, it is some answer what it has created. Okay, and perhaps it is its opinion on what the life is. Okay, so thereby your model is now in the production. Okay, you keep submitting prompt this way, okay, and you keep receiving responses this way. How does it work in actual application? So see, in application, there may be front end which is accepting a prompt. Okay, it can be any kind of front end. Okay, you can use now AngularJS, Next.js like front end you may be using to accept prompt from the user, and thereby at the server side, this Python code will interact with the model. This Python code will interact with the model, and thereby will create a response, and your front end will show that response to the user. Now here you see pre-trained predictor. Pre-trained predictor is actually has already been linked to the model. Okay, we are getting pre-trained predictor here after we call a deploy method. This deployment your application will not do. Your application will actually use a URL of that model, and using that URL, then here it will call the predict method. So that URL has to be within the payload, and then you have to call the predict method. So the point is, in real life, you will simply deploy the model. Thereafter, at the time of the so within the application, you simply have to refer to that model to submit the payload to it. And once you submit the payload to it, you will get a response, and that response then you have to echo on the screen the way you want. This is another prompt. This is another prompt. Let me run this. And here, what is the recipe of the mayonnaise? And here, a kind of a recipe, what it knows, it is showing to you. Recipe of the mayonnaise. So fine, this has become a pre-trained model, which you can access within an application using Python code. Okay, in the Python code, you will have to submit the payload this way, and payload comprises it's a hyperparameters and prompt. Okay, and then you have to, in your application, have to make an arrangement to show the response to the end user. Now let us tune the model. How do we tune the model? For this purpose, I already told you we need additional data. Okay, so here we already have additional data. Remember, this whole environment is actually working at the top of the data bricks. Okay, and that's why Databricks has the sample data. That's what I am referring to. Okay, so here I am asking through the Python code, I am asking it to load the data from the Databricks sample data reservoir. That is one thing. Okay, so here we have got the data set, and here we are preparing that data set. Okay, so for example, that data set, let me show you. Here is that data set. It has instruction, context, response, category. So instruction is a kind of a prompt. Okay, some context might have been mentioned, and here is the response. So actually, this data set is the key value pair of instruction and response, and category is also there. So here, what we are doing from this data set, we are picking up only that data which are talking about summarization. That data only we will use for the purpose of the training. Okay, so I am just collecting not all the data, but the data that is of the summarization, and on this summarization data only we want to train the model. Okay, once we get the summarization, that category column we may remove. So from this summarization only, we will pick up only those records which are summarization. This record we will pick up, and whatever other records of summarization we will pick up. This column we will drop, and thereafter instruction, context, and response. Only these three columns we will submit to it. Yes. So coming back, so I'm just reducing the size of the data set, so that only specific data we will submit. We will not submit it every type of data, and thereby we will reduce or we will put an upper cap of on the infrastructure that it will use. Larger the size of the data, it will be using larger infrastructure. Okay. Yes. So here I am creating a data set, train and test a data set. So remember, here we are splitting. Now, in case if you are already from machine learning background, you know what is the splitting. So here I am, from whatever data it has collected, I will ask it to use only 10% of the data for testing purpose and 90% of the data for training purpose. That's what train test split does. Okay, here I will get data for training, training and testing. Okay, train and test data set train. It will refer to the data, 90% of data which has been splitted for the training purpose. Okay, and 10% of data for the testing purpose. Okay, here that is done. And here then the data for training that can be seen here. Okay, and thereafter I am writing that data into JSON. So trained JSON L, and finally then that data I am uploading to S3. S3 is a simple storage service of AWS. So there I am uploading that data. So I am uploading the data for the training over the S3. And now from here, actual training will begin. So let us have a look at the code which will be doing actual training. So here you will see Jumpstart Estimator is a part of the API available for fine tuning. Okay, model ID. We know it is Llama 2 model we are submitting, model version. Okay, uh, this is something I am submitting to it uh, to give it assurance that we are following all license specific guidelines. Disable output and instance type. Here I am asking it to go with this kind of machine for training the model. This kind of machine for training the model. Some hyperparameters we are submitting to it, and here we are fitting the training data with the training data location. So from here, it will get the training data and it will start training the model. Now, this is really a long process. Okay. And for that reason, I already have, created a trained model for you. So start the training job, preparing the instance for training, downloading the output, and then here it will, what it will do, it will first of all, train the model on that data, then it will change the hyperparameters, and again it will repeat the process of the training on the different hyperparameters. Okay, here in order to ask it to complete that process quickly, I have told it to complete it within 2 iterations. But otherwise, in real life scenarios, it has to undergo multiple iterations. So it will be taking a really long time for completing this process. Sometimes even it takes around a couple of hours also to complete the process. Okay. So thereby, after it runs those 2 iterations, epoch iterations, uh, here you will get a completely trained model, which thereafter you are using to deploy. Here, once that model is trained, you will deploy it. Now, which environment you want that model to deploy for the production? So that environment also I have submitted. Excuse me. And after this particular statement got completely executed, here it will create this endpoint. This endpoint was created as a part of the deployment. Yes. And then we are using Python API, Pandas API here for doing the comparison among these two models. Okay, let me put this code to run and we will see evaluation of both these models. See, so response from non fine-tuned model and response from fine-tuned model. So their size itself gives you a difference that means what fine-tuned model means what kind of difference they make. So hereby you will get you will do a fine tuning of the model. Okay, and in order to perform this fine tuning, this kind of data we are giving, what are some unique certain tie back something is written. There are many items you can use to make curtain. It is not certain, sorry, it is curtain. Okay, so question, I mean to say prompt and answer, or question and answer also can be submitted to it, and its answers will be accordingly aligned. So this is instruction based fine tuning. Okay, API is extremely simple here. API is very simple here. See, this is a statement to do the deployment. This is a statement to train the model, to start training of the model. So API is extremely simple. The only thing is that it needs very critical hardware, and again, you are not supposed to bother about it. In case of AWS, Amazon will give you that hardware. In case of Azure will give you that hardware. Okay, so you don't have to bother about hardware, but this is a very simple way to do the training of the models. Uh, okay, would like to hear any question on this? Anybody has any question, please? But here I try to cover, what exactly generative AI is, how it is different than machine learning. In generative AI, what are all different types of models? See, covering all these things in 2 hours definitely is difficult. So I have tried my best to keep it as simple as I can. Okay, in extensive classroom training, all these things are carefully carved out, articulated, explained step by step. Okay, and thereby, all these things can be made very easily understandable to everybody in the batch, everybody in the training. So, yeah, uh, any question on this, please? In case if you want me to go back and show you some slide or some code, let me know. In case if you want me to take you back and explain something, let me know. We have ample time to do that discussion. Any question, please? So I will wait for next couple of minutes, 10, 15 minutes for your question. I am already here. Okay. If you want me to explain the things, repeat the things, I am already here. I will do it for you. But here I cannot show you execution step by step for the reason that deployment takes around 10 minutes. Training takes around 20 to 50 minutes, 20 to 30 minutes. So that's why. Thanks, Sumi.
Anybody else who has any questions, feel free to ask because sir here will enlighten you about this particular topic in detail. So if you have any questions, please ask. Don't feel shy or don't hesitate to ask.
We do offer extensive training on generative AI, including fine tuning in AWS, fine tuning and generative AI services available on Azure. Okay, so we do offer trainings on all these. There is a new topic which is really a hotbed topic today. we call it the Agentica AI. Okay, and we do offer trainings on agentic AI also. Agentic AI, not Agentica, sorry. Agentic AI. And agentic AI is going to be, very important and a future as on today, wherein here generative AI designs a stuff for you, designs a description for you. Agentic AI will do the things for you. It will not only design a stuff for you, it will do the things for you. For example, in case if HR people ask agentic AI to get a new person joined, for getting a new person joined, there may be multiple steps to be followed. Writing acquiring the profile of that person, from the profile extracting his technical knowledge, extracting his experience. Generative AI will do that. Will move that data to appropriate databases, will take permissions from specific concern authorities, and accordingly then, create employee ID for him, and lots of things what it has to do. But many such actions it can take, agentic AI. Okay, so for automating all your business processes, agentic AI is the future. I have got a new question. Just a minute. What if I have many Confluence wiki pages, and if I want to do personal trained model, then is there only solution with the Databricks? Then is there only solution with the Databricks? No. You can do it in Hugging Faces also. On Hugging Faces, you don't have to write the code. On Hugging Faces, it's a drag and drop what is available. Amazon Bedrock also offers you similar kind of thing. So that also you can use. But now here what happens, what platform Amazon is using down the line, you don't have to bother about it. What platform Hugging Faces using down the line, that you don't have to bother about. It may be Databricks. So Databricks is just a platform offering all these services, but perhaps, Azure may not be using Databricks. It may be using its own platform. Okay, the languages are also not only Python, but there are multiple languages available on different and different platform. If you use Databricks itself offers you 4 languages. Python, I think it is C sharp also, JavaScript, and one more language, Java also. Okay, so multiple languages, even Python also appears. Sorry, Databricks also offers, because Databricks runs something called as a Spark at its heart, and Spark, can work on multiple languages. Hope, Vishwa, I have answered your question.
Yes, yes.
Have I answered?
Yeah.
There are many platforms available as on today in the market. It has been very steep competition, in this race, who offers best. Okay, and many choices we have got as on today. Many choices. There are no code approaches available, where by doing simply drag and drop also you can do the thing. You need not have to learn Python for doing these things. The SageMaker offers you solution through Python, but Bedrock and other kinds of platforms, they offer you codeless or no less code or no code approaches. Yeah. Any other question, please? How to choose or create certain use case for a project to get a job ready portfolio. How to choose or create certain use case for a project to get a job ready portfolio. So do you want a solution on project specific use case, or do you want to know how you can prepare yourself and improve profile? It's not clear to me from the question. Whether you want to develop a use case for the project or whether you want to improve your profile. Not pretty clear. Can you please elaborate more exactly in your intention? You can unmute yourself. Project for resume. Okay. Okay. So thereby, what I can suggest you uh, on Azure, there are credits available. The free subscription is available for Azure. You can get a free subscription on Azure, and with that, you will get a credit of around 13,000 Indian rupees. Once you get a credit of 13,000 Indian rupees on Azure, you can learn. Uh, we call it as a Azure AI Foundry. Azure AI Foundry. In Azure AI Foundry, you will get to learn machine learning. You will get to learn cognitive services. Cognitive services and these LLMs, including OpenAI LLMs. Uh, I don't know yesterday's session. So, okay. So first of all, you will have to learn how to use AI Foundry, how to use cognitive services, how to use LLM. Whenever you are working with cognitive services, there perhaps things will come to your mind. How can you do image analysis? How can you do face detection? How can you work with a natural language processing? You know, different labs are available there, different guidelines are available there. So accordingly, first of all, you will have to learn that technology. And once you learn that technology, then you can identify whether you want to design one application for a company, so that when any company person enters into the company premises, immediately by recognizing his face, his attendance should be marked. Or whenever he is leaving the organization, immediately by recognizing his face, his attendance, his exit timing should be marked. His entry timing, his exit timing should be marked. Okay, so such type of use cases you can identify. You even can go through different and different case studies available on the internet. Okay, so to know more and more critical use cases for today's scenario. Can you share the Python notebook you showed in this very session? I don't have attachment. I cannot do attachment here. So I will have to check with Anmay, okay, how it can be shared, but there is no issue. I can share that notebook. I can share it, but I do not have right to. What is this plane? What is that plus? No, I don't know. Okay. No, I don't have right here to attach that notebook. Okay. Anmay, do we have any way to share it, or means whether we have a right to share it? Let me check with you.
I think, sir, you have the right to share it. But if it's not able to share, then you can send the file. I'll share with the participants.
Okay, I will send it to you, Anmay,
Okay, sir.
because
Sure.
I don't have right here. Since
Yes,
I
sir.
am very new to LLM models and having zero knowledge on machine learning, so whenever we do create models for a specific problem set, is there any other way than creating the model like instruction, response, etc.? Or we could feed the wiki pages links directly with some API. we could feed, which will train the underlying model instead of creating the table in tools like Databricks. Okay, okay, okay. See, there are different ways of submitting it, the data source. Wiki pages is one of the ways. Here, what I did is, means why did I use a Databricks um, say, sample data? Because that data is really available to me. I don't have to, difficult for me to get real life data. That's why I went with the sample data. But otherwise, it is possible to submit to it. Wiki pages also to submit to it in case if there are some PDF documents also, Word document also, CSV files also. So different data formats you can use to submit the data to it. Internet web pages also you can use to submit the data to it, but it is possible. Okay, I think uh, in case if you refer to the documentation, first of all, you need to decide which cloud you will use to begin with, whether it is AWS cloud or whether it is Azure cloud. I see some limitations while working with AWS cloud for the reason that in the free tier, access to SageMaker is not there. Okay, so that's why I suggested you whether you can go with Azure, where you will get a credit of 13,000 Indian rupees, and that is sufficient for you to work more and more on Azure AI Foundry. Okay, there you can do everything. So you have to first of all decide which cloud you will use to learn the things. Okay, and thereby then uh, refer the documentation. Labs are available. Okay, step by step you will have to follow and complete the lab. That is always a great learning. Such type of labs are available here also in AWS. Hmm. Yes, but first of all you will have to learn all these things. Uh, since my most experience only on AWS. Huh. Yes, yes, yes. So, uh, 13,000 is sufficient amount to learn any kind of technology over there. The only thing is you have to complete learning within a stipulated period of 1 month. Okay, you get larger time to learn on AWS, but AWS does not allow you to do everything within free subscription. Azure allows you to do everything within free subscription. So on that front, okay, Azure I will see is better for learning. Okay, attention, recording will stop in 2 minutes. I think say it is going to end, and I think let us now
Yes, sir.
conclude the session. Thanks for being here and encouraging me to work more and more on newer and newer technologies. Okay, I pay best of wishes for you for learning on the new technologies. Okay, best of luck
Yeah,
for
thank
all
you,
of
sir.
you.
Thank you, sir, for your valuable insights on this topic. And I hope that the participants might have learned something through it. And also thank you to all our participants, obviously, because we appreciate your engagement and questions throughout the webinar. And I hope that we reconnect in the future. I just want to request all the participants to fill this feedback form, which I'll be sharing on the chat. Just kindly take 2 minutes and fill the feedback form. So once you can, if you have filled it, your email IDs and all the details will be sent to the official accounts of Synergetic, so we can share the files with you, the files which you want.
So fine, let me drop myself. Okay, thanks everybody again. Thanks, Anmay, giving me chance and opportunity to present my knowledge on this
Most
new
welcome, sir.
technology.
Most welcome.
Thanks. Thanks.
Thank
See
you.
you.
Participants, kindly fill the form so that we can register your email IDs with us and we can share the files which are required for you. So once you have, if you have filled the feedback form, you may leave the session.